In this video, I want to look at the structures of the inner ear. Now, the inner ear has structures both for conversion of sound vibrations in the air to nerve impulses, and also the vestibular system, our system of balance. So we can see in this model the area that looks somewhat like a rolled up snail shell. This is known as the cochlea, and the cochlea is three tubes that we'll talk about in a different video that are coiled around roughly 2.5 times. Within the cochlea we will find the functional organ or organs of hearing, the organs of Corte, but we'll look at those in another video. Between the cochlea and these large semicircles we have an area known as the vestibule, and the vestibule, as its name implies, is associated with the vestibular system. Within the vestibule we can see two sacs here, gray sacs. We've cut it open so we can take a look inside. The top sac is the utricle and the bottom is the saccule. The utricle and saccule contain mechanisms for detecting linear motion, or acceleration and deceleration. The utricle and the saccule are filled with a fluid known as endolymph. The remaining structures here are known as the semicircular canals. As you can see, there are 3 semicircular canals in each ear, and the semicircular canals are designed to help us detect rotational motion or angular motion. They are filled also with a fluid, and here we've cut them open to represent the gray area. They are filled with a fluid known as endolymph, and at the end of each semicircular canal there is a widened area. You can see here and here. These are known as the ampulla. The ampulla is where we actually detect the motion of the endolymph within these semicircular canals. Notice the 3 semicircular canals for each major plane of the body. There is one for a transverse plane, one for a sagittal plane, and one for a coronal plane of the body, the 3 semicircular canals. Now on this model, here we see what is known as the endolymphatic sac, and it has a duct taking the endolymph down into the utricle and the saccule. It should be poised up here, but the model manufacturers made it of a looser plastic so it doesn't stay where it belongs. So the endolymphatic sac. Now if we look inside this model, I'm going to remove a portion of the cochlea, and we can see down inside the cochlea, we can see the 3 different areas within the cochlea. The pink represents our scala vestibuli, the green represents our scala tympani, and the blue represents our cochlear duct. But we will see those in another video in a much higher magnification. Associated with the cochlear duct, the scala tympani, and the scala vestibuli, we are going to have the cochlear system for conversion of vibrations into nerve impulses, and the scala vestibuli begins here at a structure known as the oval window. The stapes, one of the ossicles of the ear, will vibrate against this oval window, the beginning of our scala vestibuli. At the end of our scala tympani, we have another window. This is called the round window, and the round window releases any vibrations back into the middle ear chamber so they will not echo back into the cochlear system and be heard as an echo. Now if I rotate this around so we look at it from a slightly reverse angle, if we put this back together and take a close look at it, we can see the nerves coming from the organs of Corte forming the cochlear portion of cranial nerve number 8, the vestibulocochlear nerve. And we also see the nerves coming out of the utricle and the saccule, forming the vestibular portion of the vestibulocochlear nerve. So just a reverse angle of the cochlea, where you can see the cochlear portion of cranial nerve number 8, and the utricle and the saccule with their vestibular portions of cranial nerve number 8.